In applications of derivatives, you have seen in the first lecture the concept of geometrical meaning of derivatives. And now, in the same chapter, the another very important concept is to know the equation of tangents and normal to a curve at a given point. So this lecture is just for giving the concept of equation of tangent and normal to a given curve at a given point. And I hope you have definitely studied in your course on coordinate geometry how we find the equation of a straight line passing through a given point. Actually, that idea will be utilized here to find the equation of a tangent and a normal passing through a point on a given curve. So let us consider in this xy plane, this is a curve which is defined by the equation y equal to f of x. So this is an arbitrary curve because this function is not defined here. So I have just considered an arbitrary curve defined by the equation y equal to f of x. And let us consider there is a point P located on this curve, and the coordinates of this point P are x naught and y naught. We consider it. Okay. Now let us draw a tangent. You can see in this figure this PT. PT is the tangent drawn at the point P whose coordinates are x naught, y naught to this curve. And we also draw a normal at the same point on the curve, and this normal you can see is Pn. I have marked here this normal. Okay. Now you can see, since this Pn line which is normal is perpendicular to this tangent Pt, so this angle made at the point P, which you can read as angle NPT, that will be simply equal to pi by 2 or 90 degree. Okay. And we have shown in this figure that this tangent makes an angle psi with the positive sense of x-axis, and this normal Pn makes an angle phi to the positive sense of x-axis. Okay. So you can say that this psi is the inclination of the tangent and phi is the inclination of the normal. So if you want to define the slope of this tangent, you know that the slope of tangent, if we denote it by the symbol mt, what will be this? This will be simply equal to tan psi. But in geometrical meaning of derivative, you have learnt that this slope is equal to dy by dx, or derivative of y with respect to x at the point what? X naught, y naught. That is at the point through which this tangent passes. Okay. And you can equivalently write it like this is just f dashed or at x naught. X naught. Here there is no need to write x naught, y naught, because when you will find this derivative dy by dx, you will get a function which will be only a function of x, and you have to obtain the value of dy by dx at the particular value of x, which is x naught. So this slope of this straight line pt, which is a tangent, will be simply equal to f dashed of x naught. Okay. Now since this tangent passes through the point x naught, y naught, and you know how we can find the equation of a straight line passing through a given point. Definitely you have studied in your course on coordinate geometry. Actually this equation is simply given like this. This is given by y minus y naught equal to mt times x minus x naught. Okay, where mt is the slope of that straight line, and here our straight line is the tangent, and so this is actually the slope of the tangent. All things which I have just explained, I have written here for your convenience. You can write down these things in your notebook, and that will be a good notes. Okay, so you can see I have written that y equal to f of x is a curve, and pt is the tangent, and pn is the normal to this curve at the point p x naught y naught, and mt, which is equal to tan psi, this is slope of the tangent at point p, and mn, which is equal to tan phi, this is slope of the normal at point p. Now, as I have told you, we will obtain the equation of tangent and the normal. So, for getting the equation of tangent, you have to think about equation of a straight line passing through a given point. As our tangent is passing through this point, whose coordinates are x naught, y naught. So, on the basis of coordinate geometry, you can write that equation of this tangent will be simply equal to y minus y naught equal to mt times x minus x naught. But mt, as you can see, this is equal to tan psi, and this tan psi is dy by dx at the point x naught, y naught, and this can be written as f dashed at x naught. Here there is no need to write y naught, because I have told you when you will find dy by dx, you will obtain a function of x, and so you have to only put the value of x, which is x naught. So f dashed of x naught denotes the slope of that tangent passing through the point x naught, y naught. So now let us substitute this f dashed at x naught in this equation 1 at the place of mt, and so finally you will get that equation of the tangent will be what? That will be simply y minus y naught equal to f dashed of x naught times x minus x naught. This is a very simple formula, and you can remember it to solve the numerical problems. So this equation A defines the equation of tangent to a curve y equal to fx passing through the point x naught, y naught. Okay, I think we have clearly understand this fact. Now our aim is to find the equation of the normal passing through the same point. Okay, and you can see this figure. This normal Pn makes an angle phi with the positive sense of x-axis. So if I will ask you what is the slope of this normal, that will be simply tan phi. Tan phi, this is slope of the normal, as I have mentioned. Okay, so you can say that this normal is nothing, this is simply a straight line passing through the point P whose coordinates are x naught, y naught, and its slope is tan phi. So you can write again the equation of this normal, and at the place of slope we will have to write now tan phi. Okay, or you can say mn. So the equation of this normal can be written as y minus y naught equal to mn times x minus x naught. Here mn, you know, this is the slope of the normal. Okay, but as you have seen in that figure that this mn is equal to tan phi. Okay, now the slope of this normal can be related to the slope of the tangent. How we can relate it? And for this again let us see this figure. You can see that this triangle PTN, see the triangle PTN. Actually this angle phi is the exterior angle of this triangle, and angle psi and this pi by 2 are its interior angle. And you know from elementary geometry that exterior angle of a triangle is simply equal to the sum of the interior angles. नहीं, किसी भी त्रिभुज का जो बहिष्कोण होता है वह अंतः कोणों के जोड़ के बराबर होता है. So you can say that this phi will be equal to psi plus pi by 2. Okay. So in this way you can relate psi and phi. Okay. And let us see, this phi is simply equal to what? This is pi by 2 plus psi. And so in this expression, phi can be replaced by pi by 2 plus psi. So mn is equal to tan pi by 2 plus psi. But you know that tan pi by 2 plus psi, that is simply equal to minus cot psi. And cot psi, this is equal to 1 over tan psi. So mn is equal to minus 1 over tan psi. But what is this tan psi? You have seen that this tan psi is the slope of the tangent passing through the same point x naught y naught. So you can say that this tan psi is simply equal to f dash of x naught. So the slope of this normal is equal to uh, a reciprocal of the slope of, sorry, the page has been turned, but this will be just okay. Let us see. You can see that the slope of this normal is reciprocal of the slope of the tangent with negative sign. This is also a very important relation, and it is very important for solving the numerical problems. So remember it. Slope of normal is equal to reciprocal of the slope of tangent with negative sign. And this result can be easily seen by another method. And that another method finds its proof in when you study coordinate geometry. You have seen that when two perpendicular lines intersect one another, then actually the product of the slope of the two such lines is equal to minus 1. And here you know that the tangent and the normal are perpendicular to one another. So if mt is the slope of the tangent and mn is the slope of normal, definitely its product will be equal to minus 1. So you can say that the slope of this normal is equal to minus 1 over mt. Okay. And mt is equal to f dash of x naught. So you can see that in this way we can very easily say that the slope of the normal is equal to reciprocal of the slope of the tangent with negative sign. And so if now you want to find the equation of the normal, you can put the value of this mn in this equation too. So the equation of normal will be what? That will be y minus y naught equal to mn into x minus x naught. But mn is, now you know, it is minus f dash of x naught. So at the place of mn I have written here minus 1 over f dash of x naught. And so this equation B represents the equation of the normal to a curve y equal to fx passing through the point x naught y naught. So we have in this way obtained the equation of a normal and a tangent passing through a point x naught y naught on a curve y equal to f of x. Now you should definitely remember these two equations, because in the problem, numerical problems, you have to directly write these equations. Okay. And now I would like to illustrate this idea by taking a very simple example. So let us consider an illustrative example. The example is like this. A curve is represented by y equal to x square. Okay. This is the equation of our curve. This is y equal to fx. Here f is defined and this f is equal to x square. Okay. Then you have to find, first of all, the slope of the tangent to this curve at a point 2, 4. The second part of the problem says that we have to find the equation of the tangent to the curve at the same point 2, 4. And again you have to find the equation of the normal passing through the same point 2, 4. Okay. Actually, for solving this problem, there is no need to draw a figure. But for more clarification, more idea, I have actually drawn the figure here. But you can solve this problem without drawing this figure. Okay. Actually, definitely you have studied coordinate geometry, and where you have studied the chapter parabola, you can see that this equation y equal to x square simply represents a parabola which is symmetrical about the positive y-axis. Symmetrical about positive y-axis. Okay, and this curve, as you can see, represents the parabola y equal to x square, and it passes through the origin, because when x is 0, then y is also 0. Now, according to this problem, we have to first of all find the slope of the tangent passing through the point P whose coordinates are 2, 4. So this point lies in the first quadrant because x and y both are positive. So let us consider this is the point P, as you can see in this figure, whose coordinates are 2 and 4. And draw a tangent here. This PT represents the tangent at this point, and you have to find the slope of this tangent. Let us say this angle is psi, so you have to find tan psi. But you know, according to geometrical meaning of dy by dx, that this dy by dx represents the slope, that is tan psi. This is slope of the tangent. So if you want to find the slope of this curve at point P whose coordinates are 2 and 4, first of all you have to differentiate this y with respect to x. Okay, so so slope, I am just solving the first part of problem. Slope of the tangent, slope of the tangent passing through an arbitrary point, let us say xy, arbitrary point xy. If you write that slope mt, that mt will be equal to what? This is dy by dx at x and y. Okay, and this will be equal to d dx, and y is equal to x square. So this will be simply equal to 2x. This is the slope of the tangent at the arbitrary point x and y. But here we have to find the slope of this tangent at the point whose coordinates are 2 and 4. So mt at 2 and 4 will be what? You can see x is 2, so this will be 2 into 2, and this equal to 4. And this is actually the answer of the first part of the problem. Or you can also write this as, this is f dashed at 2, where x is 2, and this is equal to 4. Okay. Now let us see the second part of the problem. Actually, the second part of the problem says we have to find the equation of tangent passing through this point 2, 4. As you know, equation of tangent, how we can find it? Equation of the tangent passing through the point x naught y naught. What is this? this is given by y minus y naught equal to f dashed x naught times x minus x naught. Okay, but you know that we have to find the equation of the tangent passing through the point 2 4. So this 2 actually represents x naught, okay, and this 4 represents y naught. So at the place of y naught, now we will write 4, and this f dashed of x naught, this is equal to f dashed of 2, and its value is 4. So this is 4 times x minus x naught, but x naught is 2. So this equation is what? This is y equal to 4x minus 8 plus 4, and this is equal to 4x minus 4. So, and this is let us say equation 2, and this is actually your answer of second part, that is this equation represents the equation of a tangent. And you can see that slope of this tangent is 4, and it intersects the y-axis at a point whose y coordinate will be minus 4. You can see this tangent in this figure. This is actually 4 unit, and at intersection is in negative side, so you write this so you write the y coordinate of this point as equal to minus 4. Okay, now you have to find the equation of the normal passing through the same point 2 4, and you can easily find it. Third part of the problem, equation of the normal. Equation of the normal. What you have learnt just now, that equation of the normal is given by y minus y naught equal to minus 1 over f dashed at x naught times x minus x naught. But you have seen that in this problem y naught is equal to 4, okay, and you have obtained that this f dashed of x naught, which is actually the slope of the tangent at the given point, and this you have obtained, this is equal to 4, and this x naught is 2. So this is the equation of the normal, that is y minus 4 equal to minus x over 4 and plus 2 over 4. Okay, and so this y will be equal to minus 1 over 4x and plus 1 over 2 plus 4. And so you can say that equation of the normal is y equal to minus 1 over 4x plus 4.5. Again you can see this is also equation of a straight line having the slope equal to minus 1 by 4. Slope of the tangent was 4 and slope of this normal is minus 1 by 4. So both are reciprocal of each other with negative sign, and this straight line will actually intersect the y-axis in its positive side, because here this is positive, because you know in the equation of a straight line in slope form is y equal to mx plus c. So you can see this figure I have drawn here, that this normal actually intersects the y-axis at this point A, and so this intercept will be equal to 4.5. Okay, so in this way you can see, if you have an idea of finding the slope of a curve, and if the equation of tangent and normal are in your mind, you can easily solve this type of problem. Okay, thank you very much.